We are witnessing a massive shift. Tech giants are racing for ultimate control. Beyond the hype lies the real turning point. This is where the future is being written.
Some mathematical problems have literally resisted humanity for decades. They just sit there in the dark corners of theoretical science, practically daring us to find a breakthrough. Well, on August 1st, 2026, OpenAI dropped a bombshell. They announced that their internal Astra model had produced brand new results on 10 of these notoriously complex open math problems. But as we unpack this explainer today, I think you'll quickly realize that this story is so much bigger than just a list of solved equations.
Because you know what the absolute craziest, most profound part of this announcement is? It isn't just that an artificial intelligence stumbled onto some correct mathematical results. It's that this incredibly complex, abstract, human-level reasoning was actually distilled down into machine-checkable proofs. We are literally looking at a moment where totally abstract logic was translated into a format that a cold, hard computer can objectively verify. It really forces us to stop and ask, what on earth just happened inside those servers? Okay, let's dive into this. Did AI just discover something that brilliant human mathematicians somehow missed? I mean, for years, AI has basically been an amazing tool for retrieving what humanity already figured out. You ask it a question, and it gives you an answer pulled straight from its training data. But the central mystery we're unraveling right now is whether we are watching AI cross this massive, almost sci-fi threshold, moving from just regurgitating answers to actually contributing brand new, independent knowledge to the human race.
To really grasp why this is such a game changer, we have to look at the fundamental difference here: retrieval versus discovery. Think about it like this. If you ask a model, hey, what is 17 times 19? And it spits out the answer, that is retrieval. It's essentially just a calculator on steroids, right? But Asai's recent work was in insanely complex fields like quantum information, high-dimensional geometry, and group theory. Producing a meaningful, net new result in these deeply theoretical spaces isn't something you can just look up in a database. It requires real reasoning, pure logic, and a total leap into the unknown.
And this brilliantly illustrates why these fields actually matter to you and me. Take sphere packing, one of Astra's 10 advances. It's all about figuring out how objects can be packed together most efficiently in high-dimensional space. Or coding theory, which is the whole reason information stays recoverable even when digital errors happen. And then there's lattice cryptography, literally the foundation for post-quantum internet security. These aren't just esoteric little puzzles meant to make academics feel smart. They are the absolute critical infrastructure of our modern digital world and our future security.
But actually, scratch that. Let's be super precise with our language for a second. Did Astra actually discover mathematics? There's a massive hierarchy of difficulty here. There is a huge technical and philosophical gap between just solving a known problem, improving a known bound, proposing a neat conjecture, and actually producing a formally verified result. We have to carefully draw the line between an AI spitting out a lucky hunch that a human expert later agrees with and an AI producing a result that is mathematically, undeniably proven by an entirely separate computer system.
Which brings us to a really critical concept, the lien certificate. Imagine a human mathematician handing you a massive paper and saying, hey, trust me, every single step of this proof is totally correct. Historically, other humans had to spend months agonizing over the logic to check it. Now, imagine being able to say, here's the formal proof, let a computer verify every single logical step instantly. That is exactly what lien does. Now, it's really vital to note the teamwork here. The AI generated the mathematical argument, human researchers prepared the manuscripts, and then lien mechanically checked the formalized proof structure. It's literally removing human trust from the equation.
Okay, let's talk money for a second, because the economics of this breakthrough are wild. $2,000. According to OpenAI, generating these specific solutions cost roughly $2,000 in total tokens at their standard subtle API rates. But let's be crystal clear about what this number means and what it absolutely doesn't mean. It does not mean they built Astra for $2,000. That token cost completely ignores the massive astronomical expense of model training, the supercomputing hardware, the power grids, and of course, the salaries of the brilliant human researchers. It simply represents the raw inference cost to generate these specific solutions once the model was already built and ready to go.
Let's step back and see how this paints a totally distinct picture of our future. We are watching a massive paradigm shift, moving away from the traditional chatbot where the loop is just question in, answer out, to a fully agentic research AI. This new loop is vastly more complex. We're talking problem to hypotheses to experiments, results, and finally verification. The big question is no longer, can the model answer my trivia question? It's now, can this model pursue a difficult, incredibly abstract objective for hours on end and actually produce something genuinely novel?
So naturally, whenever an AI does something that's historically been reserved for human geniuses, it sparks a massive question. Why do developments exactly like this make people start talking about this singularity? Now, the singularity is conceptually understood as this hypothetical tipping point where AI becomes capable of accelerating its own technological progress, creating a sort of runaway snowball effect. Now, let's be objective here. One single event, even solving 10 crazy math problems, absolutely does not prove the singularity is here. But man, it certainly provides a window into what the very early stages of that acceleration might actually look like.
Walk through this potential scientific feedback loop with me real quick. Step 1, an AI discovers a brand new mathematical insight. Step 2, humans formally verify it. Step 3, that new insight fundamentally improves our computer algorithms. And step 4, those better algorithms are then used to improve the very AI systems themselves, which then go on to discover even more mathematical insights. It begs a truly fascinating question. How blindingly fast could scientific progress move if artificial intelligence starts improving the underlying mechanics of AI research itself?
And I want to emphasize that this matters deeply outside the cozy halls of academia. Mathematics is the invisible scaffolding for basically everything: cryptography, physics, optimization, scientific computing. Theoretical computer science isn't some shiny consumer product you can just go buy off a shelf at Best Buy, but it alters the raw tools available to all future researchers and engineers. When you improve the math, you improve the physics, you improve the engineering, and ultimately, you improve the world.
But hold on a second. As enthusiastic learners, we've got to wear our skeptic hats too. How much of this should we just accept at face value? Because scientific credibility demands rigorous, independent checking and reproducibility. OpenAI's claims are incredibly exciting, no doubt about it, but they remain corporate claims until they withstand intense community scrutiny. And those lean certificates? They're highly valuable, for sure, but they have their limitations. They only verify what has actually been formally written out. They don't automatically tell you if a theorem is practically useful in the real world.
Plus, we have to remember that OpenAI isn't doing this in a vacuum. It's an absolute arms race out there, and we have to contextualize Astra within this intense global sprint. Google is aggressively pushing the limits with its Gemini systems, Anthropic is hyper-focused on frontier reasoning, and meanwhile, a Reuters report on August 3rd highlighted some massive leaps coming out of Chinese labs, with Alibaba's QN 3.8 Max rapidly expanding its capabilities and DeepSeek relentlessly attacking the sheer economics of inference. The competition just isn't about who has the cleverest chatbot anymore. The global race is straight up about who can build the most effective, autonomous AI researcher.
So, the crucial point is what happens when you smash these two massive trends together. On one side, we have deeply falling costs of intelligence. Getting AI to just think is getting exponentially cheaper, as we've seen with models like DeepSeek. And on the flip side, we have Astra proving that models are doing much more capable, incredibly complex research. Cheaper intelligence combined with more capable research points straight toward a massive, unprecedented future increase in automated intellectual work.
Which naturally makes you wonder, if AI is doing all the intellectual heavy lifting, where does that leave us? What becomes uniquely valuable about being a human researcher? Well, our role is likely going to shift completely away from the mechanical grinding out of equations. Instead, we'll lean into uniquely human traits, asking the right questions, evaluating the true, big-picture significance of a discovery, exercising ethical judgment, applying raw intuition, and ultimately setting the research goals. We become the directors. The AI becomes the ultimate, tireless research assistant.
But let's be real, where exactly is the threshold of true autonomy right now? Can AI reliably identify unsolved problems and verify its own results with absolutely minimal human intervention? While Astra absolutely crossed an impressive barrier by solving these problems and working alongside humans to format them for lean, it doesn't prove that the entire threshold of completely independent end-to-end scientific discovery has been crossed just yet. We are getting closer, but we are not entirely there yet.
So, consider this idea for a moment. This whole explainer really boils down to this. We are getting a glimpse of what AI research could look like when it starts helping humanity discover things we simply didn't know before. This announcement doesn't mean mathematicians are out of a job today, but it marks a profound, undeniable shift from an AI that merely retrieves the collective knowledge of our past to an AI that actively helps us carve out an unknown future.
Now, what's really interesting about this is a question I'm actually not going to answer for you. At what point does an AI assistant stop being an assistant? Is it when it gives you an answer? Is it when it solves a complex problem for you? Or is it when it begins finding the actual problems worth solving in the first place? I want you to interpret for yourself where that blurry, moving boundary lies between a highly sophisticated tool and a true artificial researcher.
We'll wrap up this explainer with a final provocative thought that's been bouncing around my head. As we watch all these global AI labs fiercely push the boundaries of reasoning, autonomy, and mathematical discovery, we really have to wonder how many pieces of the singularity can appear right in front of us before we all agree on what to call it. Because, the future rarely ever shows up as one massive cinematic, world-stopping event. Most of the time, the future arrives exactly like this, as a series of quiet, brilliant clues.